Hi, this is Keely, and this is a giant algebra review. Everything you need to know about algebra for all the basic stuff. So here we go. So let's start off with this. And you can solve for more than just x. All the other letters can be solved for as well. So in this case, we're actually going to solve for y. And one thing that you need to remember is that whatever something does on one side of the equal sign, it does the exact opposite on the other side of the equal sign. So if it's being added on one side, it's subtracted on the other. If it's multiplied on one side, it's divided on the other. If it's divided on one side, it's multiplied by the other. So anytime you cross that equal sign, it does the exact opposite of what it did before. So let's take a look at this and do it more the official way first. So in this case, we've got x equals y plus z. And so if I go through, I want to solve for y, so that means I need to get rid of z. So that means I want to subtract z from both sides. Okay? And so let me write it nice. And z minus z cancel each other out, and we just get x minus z equals y. Another way you can think about this is by actually imagining moving the variables from one side to the other. So let's look at it like this. I want to solve for y. That means I got to get rid of z. It's added on this side, so when I move it over to the other side, it's going to subtract. And we've actually just physically picked it up and put it over on the other side. That's another way you can do it to kind of simplify this so it's a little bit less writing. So we'll do both for a while to get you a feel for both situations. So same equation, this time we're solving for z, so I need to get rid of y. So that means I'm going to subtract y from both sides. Now it doesn't matter that the z's in between them, because those are still going to cancel each other out. And we get x minus y equals z. And again, we can also do that same visualization technique. So I want z by itself, so I need to take that y, pick it up, and put it over on the other side. Since it's added on this side, because there's an imaginary positive number, if it was negative, it would be a negative sign in front of it. So I will pick it up, put it on the other side. So if it's positive on this side, it's negative on the other. And that means that it subtracts. And there's that one. Okay, let's work on some more. So this time we've got some subtraction going on here. So again, we want to solve for g. So I need to get rid of h. So I'm going to add h to both sides. Those cancel, and I get f plus h equals g. Now again, I'm going to use that visualization technique. And solve for g. What I want to do is, remember, get rid of that h. So I'll pick it up and put it on the other side. So since it's subtracted on this side, it'll be added onto the other side. So it'll be f plus h equals g, which is the same thing. So either method is fine. This time let's solve for h. So that means I need to get rid of g, so I want to subtract g from both sides. And when I do that, g and minus g cancel each other out. So I get f minus g equals negative h. But here's the thing, I want to find h, not negative h. So that means we're going to have to get rid of this negative sign. We need to multiply both sides by negative 1. And so this whole side gets multiplied by negative 1. This whole side gets multiplied by negative 1. Negative times negative is a positive, so there's our h. Negative times this, well, we distribute that, so negative f. Negative times a negative is a positive. And a lot of times, let's write that nicer. I want to move them around a little bit. That's perfectly fine. And there's our answer. Now let's get into some multiplication. So, again, whatever it's doing on one side of the equal sign, it does the exact opposite on the other. I want to solve for v by itself. And so I need to get rid of t. Since it's multiplied on this side, I need to divide by t to get rid of it. And so we get d over t equals v. Now again, using that visualization technique, I've got to get rid of t, so it's on top over here, so I want to slide it underneath over there. So it's just going to go and fit underneath this one. So it'll be d divided by t equals v, and we get the same answer. Either way works fine. Same thing if we're going to solve for t. It doesn't matter. It's going to be the same math as what's over here. So I want to divide both sides by v to get t by itself. Those cancel. So I get d divided by v equals t. And again, same thing with the visualization. d equals vt. I want to get t by itself. V is being multiplied. So that means when I move it across, you're going to divide by v. So it'll be d divided by v equals t. And we get the same answer there between those two again. Now here's usually where the wheels fall off. What happens if we got a fraction? If things aren't like just straight multiplication or addition or subtraction, well, we got some division going on. Well, in this case, the first one, we got to solve for f, which means that we're going to have to get rid of m. So if I rewrite this, what we're going to have to do is multiply both sides by m. Whatever you do on one side, you have to do on the other. Those m's cancel out. We get ma equals f. If we use that visualization technique, we can get the same answer. Realize that m's being divided by over on this side, so on the other side it'll be multiplied by. So we do am equals f. It doesn't matter if it's ma or am. 2 times 3 is the same thing as 3 times 2. So that doesn't make any difference there. But since it's being divided over here, it'll be multiplied on the other side. But what if we have to solve for that denominator? That's the pesky one. So we're going to do it two different ways. We're going to do it the way math would show, and then one way that's a little bit more user-friendly. So let's say we start off with this, and I want to solve for m. So in math, they'll tell you first get rid of that denominator. So multiply both sides by m. Those m's cancel out. Let's rewrite it to make it look nicer. Now I still need to solve for m, so I got to get rid of a. So I want to divide both sides by a. Those cancel, and we get m equals f over a. And then we're done. That's the answer. Another way you can do it that's a little bit quicker is what I used to call, and still do, the super secret math trick. And here's the trick to it. Whenever I want to solve for that denominator, all I have to do is swap places with those two. The m comes out and the a takes its place. So the m came out and the a took its place, and we're done. So it turns a couple of step problem into a one-step problem, and that's very handy if you're on some type of standardized test or a timed exam where you have to go fast. That's very useful. Okay, now we get into squares and square roots. Well, I've got y equals x squared, but I just want to solve for x. Well, I need to do the opposite of a square, and the opposite of a square is a square root. So I want to take the square root of both sides. And when I do that, we get the square root of y equals square root and square cancel each other out. They destroy each other, and we're just left with x. So x is equal to the square root of y. What if we got a square root? We can do the same thing. In this case, I need to get rid of the square roots. So that means I want to square everything. So that's going to be c squared equals square times, and square root cancel each other out. And we just get d on this side. So d is equal to c squared. All right, a little bit more complicated. Now they got some more stuff in here. So I want to solve for b. But I've got this half stuck in there. I want to first get rid of that. So I want to multiply both sides by 2. So 2 and the half cancel each other out. So I get 2g equals b squared. And then I want to square root both sides. I want to square root all of that side and all of this side. The square and the square root cancel each other out, so we're just left with b on this side. On the other side, we just get 2g underneath the square root sign. That's it for that one. What if we've got a square root and we want to solve for something underneath the square root? Well, again, I need to get rid of the square root, so I want to square everything. So this becomes y squared equals 3 squared, because again, you square everything. 3 squared is 9. And the square root and the square cancel each other out, and we're just left with z. Now I need to get rid of that 9, so I want to divide both sides by 9. And we get y squared over 9 equals z. And we're done with that one. Okay, now we got even more clutter. So I got d equals 1/2 at squared, and I want to solve for a. So how do we tackle this? I want to first start off by getting rid of the half. So I'll multiply both sides by 2. The 2 and a half cancel each other out on that side, and I get 2d equals at squared. I want to solve for a, so I want to get rid of the t squared. And so I can divide both sides by t squared. Those cancel out on this side, so I get 2d over t squared equals a. We can still use that visualization technique. I'll show you. So d equals 1/2 a t squared. We want to solve for a. So since 2 is on the bottom here, it'll be on the top over there. Because remember, if it's doing one thing on one side, it does the opposite thing on the other. So it'll be 2d equals a t squared. I've got t squared on top over here, so when I get rid of it, it's going to be t squared on the bottom over there, so that's going to take its place underneath. So 2d over t squared equals a. So you can think about just sliding these objects around sometimes. If you don't want to do the proper math, you can do that and still get the same answer. But what if we want to find t squared? Okay, again, I want to go ahead and get rid of the half, so I'm going to multiply both sides by 2. So we get 2d equals a t squared. I want to solve for t, so I got to get rid of a. So I divide both sides by a. Those cancel. We get 2d over a equals t squared. And now I want to take the square root of everything on both sides. The square and the square root cancel each other out. We're left with t. And this side stays the same. Square root of 2d over a. And we're finished with that one. If I want to try that visualization method, we can. 2's on the bottom here, because we're dividing by 2. So it's on the top over there. So it's 2d equals a t squared. A is being multiplied on this side, so it'll be divided by on that side. So 2d over a equals t squared. Now to get rid of the t squared, I just need a square root both sides. And I get the square root of 2d over a equals t. And you can slow things down if you need to follow along, because I'm going fast. Last group of equations. Now we got something big, giant, and long. And we want to find out just what v is on this first one. We got d equals vt plus 1/2 at squared. I just want to find out what v is. One thing we can do is we can move whole clumps of math together. We call them terms. So I can take this whole term here and move it over to the other side. So I would subtract 1/2 at squared from both sides. When we do that, we get this. It disappears on this side. We get that. And now I want to get rid of the t, because I want v by itself. So I divide both sides, and that's the entire side, by t. Just t. There we go. Almost made a mistake. Those t's cancel out, and we get d minus 1/2 at squared. That whole quantity divided by t equals v. Now, your math teacher may want you to put this in least terms or simplified method or whatever, but that's just making it look pretty. You're done right there. You've actually solved for v. Let's do the same thing, except this time, same equation, but solve for a. Again, I can move a whole clump of math over, so I'll move that. We got positive VT on this side, so it'll be negative VT on the other, equals 1/2 AT squared, because when we move it from there, it's no longer on this side, it's on the other side. I want to go ahead and get rid of that half, because we're working on getting A by itself. So I'll multiply both sides by 2, and it's both whole sides by 2. So that 2 and that cancel out. So we get 2 times the quantity D minus VT equals AT squared. Now I want to get rid of that T squared. So I want to divide both sides by T squared, and it's the whole side. So those cancel out. We get 2 times the quantity D minus VT over T squared equals A. And again, you can simplify that to make it pretty, but essentially you've got it solved for A at that moment. All right. Thank you very much for sitting through my algebra review. Hopefully this helped you with whatever problems that you may have with algebra. And remember, practice makes perfect, so keep working.